Welcome to today's topic. We're going to see about how we can leverage Kafka for ETL operations within Salesforce. So the traditional ETL was invented to move data from an operational database to an enterprise data warehouse. So ETL was typically developed in the 90s for commercial applications, which used to sell products to the customers, which were the precursors of the e-commerce applications we see today. Some of the problems with the ETL involve there is a need for a global schema. The transformations that are needed for the data elements are pretty much error prone and are very complicated. The operational cost of maintaining the ETL is also very high, and there are resources that are needed to be completely dedicated in order to ensure the ETL operations run perfectly. But the main problem has always been the narrow focus of ETL on connecting two applications and not scaling beyond that. Kafka, which was invented by LinkedIn and which became open source in 2014, kind of changed the game in the messaging domain, but it's also kind of like changing the game in the ETL domain. Kafka is a persistent, replicable, scalable, write-ahead log, which can process billions and trillions of messages per second, per day, what have you. Besides the stream processing capabilities, Kafka comes with Kafka Connect as well as Kafka Stream Processors. These two components are the essentials if we have to use Kafka for ETL operations. Kafka can act as an arterial node to connect a variety of data producers with the consumers and to do ETL among them. As part of this design, the E, which is the extract, and L, which is the load in ETL, is handled by Kafka Connect, while T, the transform, in ETL is handled by Kafka Stream Processors. Salesforce can find itself on either side, maybe on the producer side or consumer side or both. It really depends on the requirement. In such an architecture, we have several producers of different types, like we see in this diagram: mobile, web, IoT apps and devices, and diverse datasets like NoSQL and RDBMS, and many more. These applications, devices, databases write to the respective Kafka topics. The Kafka source processors then ingest these source topics and dispatch them to their respective stream nodes. This is where the transformation happens until they finally reach the sync processors. So the sync processor is right up to the end. What kind of transformations can happen? So transformations like map, filter, aggregation, window-based, late message processing, out-of-order messages, those things can be done, and can be done by creating an internal representation known as a DAG tree or topology. This is done by Kafka internally. Kafka Connect that you see at the end has inbuilt integration with Salesforce to push data inside it. So there is no coding as such required. If we flip the roles, then Salesforce would act as a producer. The Kafka Connect has the ability to listen to streaming events, platform events, or CDC events, and can route the data in reverse direction. But there will be a different DAG created internally for this purpose. Adding a new consumer producer within this design is a breeze and it does not involve the friction which is associated with traditional ETL. So built on this persistent log-based architecture, Kafka acts as a great alternative in order to meet today's and tomorrow's needs of an enterprise for ETL. Thanks for watching.